5. 5 is f of x equal 1 over 1 minus the logarithm of x. Okay, and the logarithm of x is the natural logarithm, so maybe you have written it like this in high school, or you can see it like this sometimes, but in general, if we don't specify the basis of a logarithm, it's assumed to be the natural logarithm, okay? And so here, first, we know that the domain of the logarithm is the positive x, so domain here will be, will be a subset of this, okay, because the logarithm has to be positive, and then also we need this thing to be different than 0, okay, or in other words, we want to find the x that make this equal to 0, and in this case what we have is the values of the logarithm that makes the log of x, sorry, the values of x that make the logarithm be 1, and in this case it's e, okay, so x equals e. So d is the set from 0 to e, and then from e to infinity, okay. So again, if you have negative values or 0, the logarithm of x is not defined, and if you have e, then this thing will be equal to 1 and the rational function is not defined, okay. Now 6, f of x is the logarithm of x minus x squared, and again, the logarithm is a function that's only defined when its argument is positive, so we want x minus x squared to be greater than 0, okay, or, and yeah, so this we can factor this out. And so we want either both factors to be positive or both factors to be negative. So in this case, x is greater than 0 and 1 minus x is greater than 0, or x is smaller than 0, 1 minus x is smaller than 0. This means that x is smaller than 1. This means that x is greater than 1. So x is greater than 0, x is smaller than 1, from 0 to 1, and this guy is the empty set, okay, because x has to be smaller than 0 and greater than 1, so that's impossible. So here the domain is this open interval 0, 1, okay. Now let's do 7. F of x is the square root of 5 minus x over the logarithm of x. Okay, so now we have 3 conditions, okay. First, because of the square root, this thing has to be greater or equal than 0. Then x has to be greater than 0 because of the logarithm, and the logarithm of x has to be different than 0, okay. So in this case, this means that, sorry, not that, that's it. So if, if 5 minus x is greater or equal than 0, that means that x has to be smaller or equal than 5. Then x has to be greater than 0, and x has to be different than 1. You see? So combining all these things together, x has to start at 0 and it goes to 1, and then union 1, 2, 5, closed, okay, because 5 minus 5 is 0, and then we would have 0 as the value of the function, okay. So again, it's always the same thing. You just need to count the different conditions and work with them. And then finally, 8, f of x is the arc sine of the logarithm of x. Now again, two conditions: x has to be greater than 0, because otherwise the logarithm is not defined, and then the domain of the arc sine. Okay, so the arc sine is the inverse function of the sine, and its domain, so the domain of the arc sine, let's write it like this, is this set, minus 1, 1, okay? So it's the set of all the values that the sine function can take. And so that means that the logarithm of x has to be between 1 and minus 1. Or in other words, that, okay? And now, okay, so if you plot the logarithm, it does something like this, okay, and this is 1. So there will be a value here that does it be minus 1 and 1, okay? And so, okay, so we want to find the values that make this, and every value in between will be valid for this function, okay? So yeah, the value that of the log of x that makes the logarithm be minus 1 is e to the minus 1, okay? And then this is this, and the value that makes the logarithm be 1 is e, okay? Or if that's the way you can do it graphically. If you want to do it algebraically, we can exponentiate everything here. So this is e to the minus 1, and then e to the logarithm of x, which is x, and then e to the 1, which is e, okay? So x has to be between e to the minus 1 and e. And so that's the domain, okay? Because it has to be greater than 0, but that's okay, already included, so that's it. And that's the end.